part 4, removing coefficients with powers. What this video will be about, separating the coefficient from the variable with the power, and learning about absolute values and what they are. Firstly, what are absolute values? Absolute values are like x with those two vertical parallel lines around it. But why do we need absolute values for this video? And most importantly, what they do? Now, we have to know something. X could be positive or negative, and that could help us explain how to use absolute values. Now stay with me. If x is positive, it would be just x, right? But negative, it would have to be absolute value of x, because it would turn into a positive either way. That's the thing about absolute values. Anything negative inside the absolute value will automatically turn into positive. So it's important to use absolute value with x either way. What are absolute values? Quick part 3 recap. In the previous video, we learned how to use connections from variables to solve actual radical problems. The square root of x to the power of 2 is equal to x. Well, now we have to think. X can be positive or negative. This invents absolute values. That's why the square root of x to the power of 2 is equal to x with those two parallel lines, which means that x could be an odd power if it's just alone, or it could be an odd power if it is a power of 3, a power of 5. But why do we need this information? Because negative x times negative x times negative x would equal negative x. And if it's an even power, well, it would just turn into a positive nonetheless. So we need absolute values for odd powers because they help us explain, well, why we should turn that odd power into a positive. And of course, we have to review even powers inside the root is equal to half the exponent, which means x to the power of 4 would obviously equal x to the power of 2 outside of the radical. But remember, that x to the power of 2 would not have the absolute value because it has an even exponent. So, just to recap, anything that is odd will have the absolute value. Anything that is even, you leave it alone. And most importantly, do not have the exponent inside the absolute value. That goes outside no matter what. So, without further ado, let's go ahead to our examples. Example 1. Let's try the square root of 8x to the power of 2. Let's do this old style. We split the roots. Square root 4 times 2 and square root x to the power of 2. 4 is equal to 2 outside of the root. So it would be 2 square root 2. And then we still need to simplify x to the power of 2 inside the root. So x to the power of 2 would equal x as an absolute value. And that's why the answer would be 2x absolute value square root 2. Now we are down to our second example. Let's try square root 50x cubed. We simplify it first. Square root 25 times 2 times x to the power of 2 times x. First, we have to simplify square root 25, which equals 5. Square root x to the power of 2, which equals x with the absolute value. It is a singular, it is alone with no power, so it would still be with absolute value. Because x, just stranded alone as a negative, would still be a negative, right? And then we would have the answer 5x with an absolute value with a square root of 2x. Now let's try example 3, which is square root 36x to the power of 4. Now we know that 36 is a common square of 6. And x to the power of 4, we turn that into x to the power of 2, so it would obviously be 6x to the power of 2. There's no parallel lines needed because it is even. Even numbers and odd numbers. Odd has parallel lines, even does not. This is the final example. This is going to be a little challenging, but we're going to get over it and it'll be easy for us. The square root of 75x to the power of 7 is equal to square root 25 times 3 times x to the power of 6 times x. Now let's simplify it even further. The square root of 25 equals 5. The square root of x to the power of 6 is equal to x with the absolute value and 3 outside. We can finally see an example of an exponent being outside of the absolute value. So now our final answer would be 5x with an absolute value to the power of 3. And then this 3x right here, which equals a 3 right here and x right here, they're both remainders. They don't simplify any further, so they go over here. Thank you for watching and learning about absolute values and learning something new about radicals. I hope you had fun, and I hope you keep watching more videos like this. Thank you.